Hi, this is Scott Howard with Buyer Security. In this video, I'd like to give you a brief introduction to the Tofino security solution and the various components that make up the product, and go through a sample configuration session. If you've seen the other videos that we've produced, you know that Tofino is all about defense in depth. Our goal here is to divide up our control network into security zones, isolate the zones from each other with the Tofino security appliances, and control what traffic is allowed to pass between those zones. So the Tofino solution is made up of three key components. The first component is the actual hardware device, which we call the Tofino Security Appliance. The second component is the configuration tool, which is called Central Management Platform. This is a software program that runs on a Windows PC somewhere in your plant network, and it allows you to configure, test, and manage all of your Tofino appliances from one place. The third key component are a set of firmware modules called loadable security modules, and these are dynamically downloaded and installed into your appliances using the CMP software, so you can choose what security features you have in each zone. Quick look at the hardware device. The Tofino Security Appliance is a 2-port Ethernet appliance. It runs from DC power like a PLC. Now, most important here for our sample config session is to identify the specific Ethernet interfaces. The upper one on the front panel is called the untrusted interface, and the lower one is called the trusted interface. Now, usually what we do is we would connect the protected devices to that trusted interface. It actually doesn't really matter. The device is symmetrical. Rules can be written to allow traffic to go through the device in either direction, and a protected device is connected to either interface. But it's important to know the name of each interface when we come to actually configuring the device in the CMP software. So I'll come back to that point in just a minute. So just a review again of how the device works. It is a layer 2 Ethernet bridge, and it has no IP address. So this means it's very secure. There's no IP address, so there's nothing to attack. It also means that the device can be added to an existing plant network without any configuration. There's no IP address to set. There's no other switch settings. Also, none of the loadable security modules are installed on the device when it ships from the factory, so it will bridge all traffic through the device when it's added to the network for the first time. And because it's layer 2, you can add it wherever it needs to go in your plant network without requiring any changes to the rest of the network. Your IP addresses can stay the same, your network design can stay the same. After the device is added, we can connect to it with the CMP software, and we can use the various LSMs to provide firewall protection, including traffic filtering and rate limiting. We have a range of special rules that perform more in-depth traffic filtering. And we have a range of what we call enforcer modules, which provide content inspection for specific industrial protocols. Today we're going to just get into a basic session with the firewall. So the second key component is the CMP software. CMP is a graphical config tool, and the goal of CMP is to first of all create a model of the network that we're protecting. We model each device with an icon, so each controller, each computer, and each Tofino is represented in our network model as an icon. We would then use the graphical editors to create firewall rules, content inspection rules, and whatever security features we need to protect our plant. We then have an opportunity to test that configuration before we actually go live with it. Once we're happy with the way it's running, we can then deploy it into operational mode, and now we can use CMP to manage and monitor the security system. Let's talk about the LSMs, the third key component. These are firmware modules that can be downloaded into the appliance to get the specific security features we want in each zone. So almost everybody uses the firewall, and that's the module we're going to look at today. There are several others available which we will cover in other videos. So the firewall is like a traffic cop. Essentially, the control engineer, when he configures the Tofino system, will specify to the firewall which devices are allowed to talk to each other and what protocols they're allowed to use. The Tofino firewall behaves like a whitelist. This means that if any traffic shows up that does not match a rule in your firewall rule list, then that traffic will be blocked. And it will also generate an alarm message for that traffic. So this means we can get pretty good security using a relatively small set of rules. Now the flip side of that is that we have to make sure we have a rule to allow every single piece of traffic that is required for our plant to operate correctly. So we achieve that with a special mode of operation called test mode. Like most other devices, Tofino has a passive mode where you can turn the device off. All traffic will be passed through the Tofino, nothing will be blocked. It also has an operational mode. So in operational mode, the device will allow only traffic that is permitted by our firewall rules, and it will generate alarms for any traffic that doesn't match those rules. The third mode of operation is test mode. In test mode, the Tofino will allow all traffic to pass through the device, but it will check the traffic against the firewall rules, and it will generate alarms for any traffic that would have been blocked if the device was in operational mode. So this is a really great way to try your rules in the real network with real traffic with no risk of accidentally shutting down part of your plant. If traffic is blocked by your rules, it will still go through the device in test mode. However, it will generate an alarm which will show up in this event view window in the CMP software. So you'll get a list of alarms here, and they have a lot of detail about the type of traffic, which device it came from, where it was going, and so forth. So this gives you a chance to edit and test your rules in a safe environment and get to the point where no more alarms are being generated for normal plant network traffic. And once we're at that point, then we can be confident that our firewall rules are correct and complete, and that we won't accidentally shut the plant down when the Tofino is switched to operational mode. So today we're going to go through a sample config session in a very simple network. There are only 2 devices in our network right now. We have a Windows PC that runs HMI software. It's this device here at address 1.15. And we have a PLC at address 1.1. And these 2 devices communicate using Modbus protocol. What we want to do is add a CMP computer to this plant network and add a Tofino Security Appliance so that we can protect that PLC against potential disruption from sources on the control network. This is a simulated chemical blending plant that implements the network we just looked at. So in our top window here we have the HMI software, and it uses Modbus protocol to pull process variables from this PLC in the lower window, which runs this simulated blending plant. In this chemical blending station, we are pumping chemicals into a blending tank with these fill pumps. The tank has a certain level of material in it, which is indicated by this bar graph of lights on the front. The blended material is then moved to the next stage of the process through this drain pump. Now on this demo panel, we can actually control the speed of the drain pump. You can see that as we click these increase and decrease buttons, the speed of the drain pump is changing on the HMI panel. When we do that, the PLC is running a PID loop to manage the level of the material in the tank. So it's controlling the speed of the fill pumps to try and keep this tank at a constant set point of 600 liters. So this is our simple plant network. Now right now the Tofino is wired into the network, but it's in what we call factory reset mode. It's completely passive, which means that it is not changing any of the network traffic that is passing through it between the PLC and the rest of the network. It's essentially behaving like a 2-port Ethernet switch right now. So what we want to do is we want to connect to this device using our CMP software. We want to configure it, and we would like to test our configuration so that we know that this little PLC is going to be protected. So here's Tofino CMP running on our PC. As I mentioned earlier, the main focus of the CMP software is first of all to build a model of our plant network in this built-in network editor. We'll then create and test our firewall rules and then deploy the device in operational mode. So we want to represent each device in our plant network with an icon in the network editor. So we can do that by dragging and dropping icons from the nodes view into the network editor. Here I'm dragging and dropping icon for the Tofino, and when I do that, it asks me to give the device a name. I'm just going to call it my Tofino. And I can also set up the location. There's some critical information that CMP needs to communicate with this device. Most importantly, it needs the Tofino ID, which is a unique serial number that is attached to every single Tofino device, and it's unique to every single device that leaves the factory. Now we can read this ID number off the label on the front panel and punch it in manually. That's a little bit time-consuming and error-prone. What we can do instead is to actually have CMP scan our plant network and discover which Tofinos are installed in our network and add that information automatically. So I'm going to right-click on the plant network icon, and I'm going to select this menu item, Create New Tofino SA Discovery Scan. When I select this menu item, a new dialog pops up where CMP asks me to select a range of IP addresses that I want to scan to find my Tofinos. Now, remember earlier I said the Tofino device itself has no IP address. So the IP addresses that I'm scanning are actually devices that are located on the other side of the Tofino. So I need to have at least one IP address of a device that's on the far side of the Tofino so that that discovery traffic from CMP will pass through the Tofino on its way to this device. In the act of sending traffic through the Tofino takes a look at that traffic, recognizes it as a discovery request from the CMP, and it will respond back to the CMP to identify itself. So let's go ahead and do that now. I'm going to click OK on this discovery scan. CMP is going to run the scan. Sure enough, it did discover a Tofino with a fairly long Tofino ID number attached to it. So now this Tofino icon that was discovered here can just be dragged and dropped into the network editor and added to our network model. So like before, I'm going to go ahead and give it a name. I'm going to call it my Tofino. Click the next button. I can set up a location if I like. Now, as a result of the Tofino discovery scan, the ID is already discovered. All I have to do is hit the finish button. When I do that, CMP asks me, do I want to set this device to passive mode? The answer almost always is yes, I do want to do that. And the reason is that when we set the device to passive mode, the CMP will issue a command to the Tofino so that the CMP can monitor its status from then on. It also uploads an authentication key, a unique randomly generated authentication key to the Tofino appliance, which ensures that the appliance will only recognize commands from my installation of CMP. So this avoids an issue with a potential attacker trying to take control of my Tofino appliances with a rogue installation of the CMP software. He doesn't have the authentication key, and therefore the Tofino will ignore commands from his CMP. Now the next question Tofino's asking me is, would you like to deploy some loadable security modules? Yes, I would. Remember that the Tofino, as shipped from the factory, has no loadable security modules installed on it. I do need some of these loaded up and activated in order to get useful work done in the Tofino. So for the purposes of our sample session, I'm only going to activate the Firewall security module. So I click on it in the list of modules, click the Activate Module button at the bottom, expand that a little bit. Now the CMP is actually downloading firmware to my security appliance and installing it, and it's now activated. Now I can create the rest of my network model by dragging and dropping icons into the network editor. I'm going to drag an icon from my HMI computer, and I'm going to give it an IP address. My HMI, if you recall, is address 1.15. And I'm going to drag another icon from the nodes view and drop it right on top of my Tofino here. We'll talk about that in just a second. So I'm going to call this PLC. I'm going to give it the IP address of the PLC, which is 192.168.1.1. Now you might wonder, why did I put the HMI up here above the Tofino and the PLC below the Tofino? Well, remember earlier when we talked about the fact that there are two Ethernet interfaces on the Tofino appliance, and the Tofino actually doesn't care which devices are connected to either interface. It's a layer 2 Ethernet bridge. It will happily bridge traffic through either direction based on your firewall rules. The difference here, though, is that CMP needs to know which device is connected to which interface, because when it creates firewall rules for the Tofino appliance, it includes a specification in that rule of the physical device that the traffic should come in on and should leave on. And this is to avoid an attacker trying to spoof an IP address on the wrong interface. So when we connect devices to the trusted interface, the lower interface on the front panel, we want to make sure that those devices are below and to the right of the Tofino icon in the CMP network editor. This is an indication to CMP that the PLC device is actually connected to this lower trusted interface like we see here in the screenshot. And you want to make sure that you have mapped devices in your network editor to match the physical wiring of the actual plant network. If you get this backwards, things are just not going to work. So I've gone ahead and done that. Last step now is I want to create some firewall rules to allow my HMI and my PLC to talk. So when I double click on the settings for the PLC, you can see that there's two tabs. There's a General and Communications tab, which lists the name and the IP address and so forth. And there's also a Firewall tab. This tab appears on any device that is downstream of a Tofino device in the network editor. So this means I can create firewall rules for traffic that is directed to this particular PLC. There's two types of rules here, global rules and talker rules. Today we're just going to focus on talker rules. A talker rule is a one-to-one connection between a device that's upstream of the Tofino and our protected device, in this case the PLC, which is located downstream of the Tofino. So the way I create a rule here is by dragging the icon for an upstream device and dropping it here on this talker rules list. That designates this HMI as being permitted to talk to this PLC. That's why we call it a talker. Next thing I want to do is specify what protocols we're going to allow this HMI to use. And in our system, we know we want it to be able to use Modbus, so I'm going to drag the Modbus TCP protocol from the protocols list in the lower right corner of the CMP software and drop it on top of the HMI icon in the firewall rules list. This now creates a firewall rule that says these two devices can talk to each other and they can use Modbus TCP. And because the firewall is a whitelist, we're saying that that's the only traffic we're going to allow to reach this protected PLC. If the HMI tries to use any other protocol other than Modbus TCP, traffic will be blocked. If any device other than the HMI tries to talk to the PLC, then that traffic will also be blocked. And in both those cases, when traffic is blocked, an alarm message will also be generated. So for now, I think this is my minimum rule set that I need for my plant to operate. Let's go ahead and save that firewall rule to the Tofino. You can see down here in the bottom right corner there's a status message letting me know that it's saving those changes I just made. Now I want to go ahead and test those rules. So we want to change the Tofino's mode, which right now is in passive mode. We want to go ahead and change that Tofino appliance to test mode. So recall that when the Tofino is in test mode, it will still let all traffic pass through the device, but it's going to tell us through the use of an alarm message about any traffic that would have been blocked if the Tofino was operational. Now, so far, everything is still working fine with my HMI. You can see that it is still responding to changes in the plant. Let's simulate some traffic that is not allowed by my firewall rules. I'm going to ping the PLC from my CMP computer, Now in test mode, the ping is let through. You can see I did see responses to my ping command. However, CMP is generating some alarm messages here. Let's have a look at one of them. So what I'm seeing here is a message from the Tofino saying, hey, I'm in test mode, so this traffic got through, but if I was in operational mode, this traffic would have been blocked. And here's all the detail about the traffic that the alarm message is documenting. So it tells us quite a bit of information about the source of the traffic. In this case, it's coming from my CMP computer, which is address 1.20. It's going to my PLC, which is IP address 1.1, and the protocol is ICMP. My ping command here uses a protocol called ICMP echo request. So here's an example of how we might be testing our firewall rules before we deploy the Tofino into operational mode. This ICMP echo request or ping command is a very useful diagnostic tool that we might actually want to allow in our network. So let's go back and add a rule to allow this traffic. So I want to create a rule that will allow any device in my control network to ping this PLC. So let's go to the PLC's firewall tab. I don't want to specify only one device to be able to ping this because I might have other PCs that are used by our network managers to troubleshoot network problems. So let's create a global rule. So a global rule allows any device to reach this PLC using the specified protocol. So if I just grab that ICMP ping protocol and drop it on this global rules list, what that does is it tells Tofino, let anybody upstream of the Tofino send a ping command to the PLC. I'm going to make one little refinement to these rules. I'm going to set the direction here. Right now, they're both set to bidirectional, and this means that we're saying that not only can the upstream device send commands to the PLC, but the PLC can also create connections outbound to those same devices. Well, PLCs don't connect outbound in general on Modbus. They are Modbus masters, meaning they wait for an external device to come in and connect to them. So let's change the rule to reflect that behavior. Same thing with the ping. We don't want this PLC to be able to ping outbound to devices in our network. We only want to allow incoming ping commands. So I've changed the direction now on both of these rules to incoming, which gives us a little bit better security. I'm going to hit the OK button, and we will save those changes. So once those changes are saved, let's go ahead and retest that and see if we got it right. So I'm going to acknowledge those alarm messages we got. Now I'm going to try that ping command again. This time the ping gets through and no alarm message, so that's a good thing. That's working exactly the way we wanted. Now you may have seen while we were doing this task that there were other alarm messages that popped up in my event view. I do have some other types of traffic on this network that I need to create rules for. But this is an example of the edit and test cycle that an engineer would go through with the Tofino in test mode so that we can make sure that we aren't going to block critical network traffic when the system goes live. In our next videos in this series, we're going to explore some of the other loadable security modules for the Tofino product, including the content inspection modules and the secure asset management module. Thanks for your interest today. I hope this was helpful. If you have any questions or you'd like to know more about Tofino, please feel free to contact your Belden Hirschman representative.